Welcome to Study Loop.
So we have this door here that's, oops, don't want to erase. That's initially at rest, and where a clump of mud comes in and sticks to it and causes the door to start to swing about this axis here. The door has a total mass of 40 kilograms, has a height of 2 meters, which we don't actually need to know, and a width of 1 meter. The mud hits right at the center of the door, so W over 2, or half a meter from the rotation axis, and the mud has a half a kilogram mass. It's initially going at 12 meters per second, and the door is initially not rotating or moving. So there's conservation of angular momentum about this axis here. So the angular momentum about that axis initially is just that of the mud that's coming in, and that's m2 w over 2 times the initial velocity of the mud. And that has to equal the angular momentum after the collision, and that is the mass moment, or moment of inertia, of the system times the angular velocity of the system. Now, because the mud sticks, we have this contribution for the mass moment from the mud. And then if this is a uniform door, we just get 1/3 m1 w squared for its mass moment about this axis here, about an edge axis. Now, this equals this, so we can start looking and canceling things out. We can see we get a w that cancels out. And then we wind up with, we can solve for omega 1, which is what we want. Omega 1 equals m2 v initial divided by w times m2 over 4 plus m1 over 3. And plugging in all the numbers, we get that 0.223 radians per second. And so let's look a little bit if this makes sense. Well, if m2 were 0, then the w1 is going to be 0, because basically that's saying nothing hits the door. And likewise, if v1 is 0, w1 is 0, because basically there's no velocity. You just have some mud hanging on the door and it wasn't actually coming in. As the door gets wider, the angular velocity goes down, and that's basically because J goes up faster than this. Well, if it's still hitting at the center, J goes up with W squared, but the initial angular momentum just goes up with W. So if we're just, if it's always at W over 2, so we can see that that's why that happens. Then obviously as the mass of these things go up, well, as the M1 goes up, we get that this goes down. As M2, basically we have M2 in the numerator and the denominator. So, if M2 got really big, so if the mud weighed a whole lot with respect to the door, then this would dominate over this, and we'd get, those would cancel. So that makes some sense. Now, we're asked about, including this mass moment, or moment of inertia of the mud. Well, the moment of inertia of the mud is m2 over 4 w squared, and the moment of inertia of the door is m1 over 3 w squared. And so that ratio is 3m2 over 4m1, and that's 1.5 over 160, or about 0.009. So what we're saying is that actually this term here is very small compared to that term there. And so we could probably just neglect that, and we'd get something very, very close to this.